So we just covered salts, acid, bases, and water, and now we're moving into our organic molecules. So the organic molecules we're going to be covering are carbohydrates, lipids, proteins, and nucleic acids. So we are going to start with carbs. First, what is a carbohydrate? Let's split up this word. Carb, carbo, refers to carbon. Hydrate refers to water. So when you look at the structure, let's say, of glucose, C6H12O6, you can see that it follows a certain pattern. You have a C. You have a C, and then you have an H2O. So if you put a number of carbons in there, so for example C6, well, I know for that number of carbons I have 2 hydrogens. So this is H12, and then again O6. If you've ever looked at a carbohydrate, and let me throw up a picture of one. Alright, here's this picture. Cool. So if we look at these different carbohydrates, and we use this formula, so we have carbons. If you can look at all these in this ring, this is a carbon, that's a carbon, 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 carbon. And then attached to those we have an OH and an H, an OH and an H, OH and an H, OH and an H. And let's go to the next one. We've got a carbon with an OH and an H, carbon. You get my point. Carbohydrates have carbons and waters attached to them. So that's the structure of one. If you ever see one, he doesn't really do structures on his test, but if you have to identify something and you're having some trouble, look for that. The rings also help. So we have these 5 and 6 membered rings. We differentiate those into pentoses and hexoses. So if you remember your roots for shapes, you have a pentagram or a pentagon or a hexagram and a hexagon. So pent means 5, hex means 6, and then ose, this is a really important thing to remember. Ose means sugar, so we have lactose, fructose, ribose, deoxyribose, galactose, fructose, glucose. So if you see ose, then you know that you're dealing with the sugar. So that's the one way to recognize. If you've never seen something in your life, look for some root words. Alright, so what are carbohydrates? There are sugars and starches. This is, for us, this is, for humans, I should say, main source of energy. So this is what we're using, and specifically humans use glucose to convert into ATP, which is our energy molecule. Main source of energy. So the human body is specifically designed around glucose. We always go after our sugars before we go after our fats. And then we need to separate the differences between different levels of organization, I guess you could say. So we're going to separate monosaccharides, disaccharides, and polysaccharides. So monosaccharide. Let me just write them. Alright, so some things to note about each. Monosaccharides are sweet and are absorbable. So if it's not a monosaccharide, it can't get past the wall of our small intestine. That's where you absorb all your nutrients. We'll learn that next semester when we do digestion. But the small intestine is wherever all these nutrients are going across. So if it's not a monosaccharide, and the monosaccharides that we're absorbing are glucose, fructose, galactose, and then we have these deoxyribose and riboses. So these are our monosaccharides. Mono meaning one, saccharide meaning sugar. So this is saying one subunit of sugar. If we put 2 monosaccharides together, so for example, let's do glucose and fructose. Glucose and fructose makes sucrose. So if we're naming our monosaccharides, we have a couple different ones. Let's do glucose, fructose. So everyone's heard of glucose. Everyone's heard of high fructose corn syrup. So this new one that you'll have to remember is galactose. Okay. And then we also had ribose and deoxyribose. You've seen this with DNA before. But the one thing that you can remember for all of these, deoxyribose, the one thing you can remember with all these are they all end in ose. So you know with the ose, you know that you're dealing with the sugar. So these are what you can absorb into your body. If you put two of those things together, so something like glucose plus fructose, that's going to give you your table sugar, which is called sucrose. And this is a good example of where we can show that example of dissociation versus dissolving. So remember, organic compounds are going to dissolve, not dissociate. So if I've got my water here, and now instead of just having a bunch of little circles of sugar, let's say I have my sugar cube. And the sugar cube is, I'll just do 6 for now, just to make it easy. So the sugar cube is glucose, fructose, glucose, fructose, glucose, fructose. Now once you put this sugar molecule in there, you'll get a glucose, and a glucose, whoops, and fructose is around. So this is showing that you're not breaking glucose down any smaller than glucose is. All this is showing for dissolving is you're taking something that was put together, these were bonded together, glucose and fructose, and you separated that bond, but you're not breaking up these individual monomers. So monosaccharides are the smallest subunit of sugars that you can get to. You can't break those down anymore. So these are what we're absorbing. So fructose is one, lactose is another one, and then maltose is another one. You don't have to know the combinations of the different monosaccharides, though. I just want to give you that example. So monosaccharides, these are your examples. Your examples for disaccharides are going to be sucrose, maltose, and lactose. These sugars can't be absorbed by the human body. Why? Because they're a disaccharide. They're 2 subunits of sugar. They're too big. So they have to be broken down. The sucrose will have to be broken down to an individual glucose and fructose molecule, and then those can go across the small intestinal wall into the bloodstream. Alright, polysaccharides. We're going to look at how humans versus plants store polysaccharides. So poly meaning multiple, saccharide meaning sugar. So this is multiple sugars meaning 3 or more put together. Polysaccharide. Humans, we're going to do glycogen. Glycogen is a bunch of glucose put together. So lots of glucose. Plants, they do starch, and starch is just binding glucose in a different way. So it's the bonds in there, that's way too much biochemistry to get into, but the bonds in glucose, or the bonds in glycogen and bonds in starch are a little bit different, but they're both just huge chains and branches of glucose. So this is how we're going to store our glucose. We store glycogen so that we can have access, like in case we don't have access to food for a while, then we have this storage unit of sugar that we can use for energy. Glycogen is stored in the muscle and the liver. That will be important to remember for the rest of the class. Okay, cool. Let's move on to lipids. Anything to recap from here? Carbs, that's their structure. We differentiated pentose being 5 and hexose being 6 carbon sugars. They're our source of energy for humans. We have monomers or monosaccharides. Put 2 of them together to get a disaccharide. Put a bunch of them together to get polysaccharides. And then we differentiated how humans and plants are storing these polysaccharides.